blockchain, on utilise le consensus algorithme. Et vous avez plusieurs types d'algorithmes de consensus. Vous avez le proof of work, ça veut dire preuve de travail. Après, il y avait la sortie de proof of stake. D'accord? So, there are two types. Okay, there are two types. Or we can divide, or we can the blockchain consensus algorithms can be divided in two main types. The first one is proof-based consensus algorithms, which are commonly used in blockchain, in public blockchain, while the second is voting-based consensus algorithms, which are widely used in private and consortium blockchains. So for the proof-based consensus algorithms, in this class, verifier nodes, on les appelle في البيتكوين les miners. Verifier nodes, ça veut dire les nœuds vérificateurs. Verifier nodes are required to prove that they are more qualified than others to obtain the right to add a new block to the blockchain and win the rewards. Okay, while for the second type, voting-based consensus algorithms, in this class, verifier nodes are required to share the risk of their verification process, a new block or transaction, before the final decision is made. I just cited in my slide proof of work and proof of stake. Okay, proof of work is proof-based consensus algorithms, while proof of stake is voting-based consensus algorithms. So with proof of work, it requires a participant nodes to prove that the work done are submitted by them qualifies them to receive the right to add a new transaction to the blockchain. However, this whole mining mechanism of Bitcoin needs high energy consumption and longer processing time. For the proof of stake, it involves allocation of responsibility in maintaining the public ledger to participant nodes in proportion to the number of virtual currency tokens held by it. However, this comes with a drawback that it promotes crypto coin saving. Okay. Now let's move to the second part of my presentation. So we will talk now how to propose blockchain technology for the Internet of Things. First, what is the Internet of Things? The Internet of Things, or IoT, is a system of interrelated computing devices, digital machines, objects, animals, or people that are provided with unique identity and the ability to transfer data over network without requiring human-to-human or human-to-computer interactions. And what is an IoT ecosystem? An IoT ecosystem consists of web-enabled smart devices that use embedded systems, such as processors, sensors, communication hardware, and in order to collect, send, and act in data that acquire from their environment. So IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge devices where the data is sent to the cloud in order to be analyzed locally. In 2021, IoT Analytics accepts the global number of connected IoT devices to grow 9% to 12.3 billion active endpoints. And by 2025, there will likely be more than 27 billion IoT connections. And this is very important. And many PhD students now working in IoT networks. For the security challenges, IoT security and privacy issues So the Internet of Things connects billions of devices to the internet and involves the use of billions of data points, and all of which need to be secured. Okay, um, because IoT devices are closely connected, all hacker or attacker has to do is exploit one vulnerability to manipulate all the data. Okay, hackers aren't the only threat to the Internet of Things. Privacy is another major concern for IoT users. For instance, companies that make and distribute consumer IoT devices could use those devices to obtain and sell user personal data. Okay. What is the benefits of IoT and blockchain? The integrity of IoT and blockchains uh, opens the door for new possibilities that secure and improve transparency for all involved parties while enabling secured machine-to-machine transactions. Okay, so we use blockchain in Internet of Things only if we need or if you want to secure communication inside the Internet of Things. Okay, and this is important question. This is important slide. So we use blockchain technology only if we need to secure. The blockchain technology can be effectively applied in almost all domains of IoT. For example, Industry 4.0, software-defined networking, edge computing, Internet of drones, Internet of cloud computing, Internet of energy, Internet of sensors, Internet of vehicles, IoT agricultural, etc. But some researchers now propose the use of blockchain in this or that scenario, but it may not be not visible or reasonable. In some cases, it's not necessary to use blockchain to solve these problems, and there are many other better solutions. Ça veut dire quoi? Ça veut dire que des fois, il y a des chercheurs qui utilisent la blockchain pour sécuriser, mais parfois, on a d'autres solutions pour sécuriser, mieux que la blockchain. OK? Vous posez la question quand on utilise la blockchain et quand on n'utilise pas la blockchain. Bon, in this slide, in this flowchart, so we have published this flowchart in our recent article published in IEEE, Internet of Things journal. So this flowchart explains when to use a blockchain-based solution in IoT application. So for deploying a blockchain solution, the first step is definition of IoT networks model. Then, if the data is needed to be verified by the IoT entities without any central authority, okay, and the IoT applications demand a decentralized security framework. The IoT applications use a peer-to-peer exchange among nodes at the same level. If yes, okay, we can deploy a blockchain-based solution. But if the data is not needed to be verified by the IoT entities, in this case, we can deploying the PKA solution based in certificate authority service. If the IoT applications demand a decentralized security framework, if the IoT application not need to demand a decentralized security framework, we can use another solution, okay, like a centralized security architecture, such as firewall, virtual private networking, two-factor authentication, etc. Also, if the IoT applications don't need to use peer-to-peer exchange among the nodes at the same level, we can deploying a remote server authentication. The last one is the ledger copies. If the ledger copies are not needed to be synchronized across all of the IoT entities, in this case, we can deploying cloud security gateways. So this slide is for for the PhD students that are excited to work in this field. How to propose a new blockchain-based solution for the IT network. Okay. Step one is about configuration of the IT network. For example, fog edge computing, NS cloud computing, etc. Step two is about selection of consensus algorithms. So what are the consensus algorithms that needed to be used in our works? For example, proof of work, proof of stack, etc. Step three is about definition of the security and